antiderivatives and indefinite integral. So since Calc 2 is all about antiderivatives and integrals, indefinite integrations, right? We're not going to go too deep. I'm just basically going to give you more of a, this class will end with an introduction to antiderivatives and integration. Okay. So you know how derivatives first started with like power rules, right? It was pretty simple. I mean, at least now looking back, I hope it's simple. So this will be basically undoing the power rule. So we won't be doing like crazy stuff, like undoing the chain rule would be very difficult. We'll say that will be for some other class. So we're going to do just some basic stuff. Let me give you the background. So a function, capital F, is the antiderivative of F on an interval I when F prime of X equals F of X. Let me write that a little better. That should be a capital F. And this is a lowercase f here. For all X in I. So here's the first theorem for chapter 5.1. So if capital F is an antiderivative of F on an interval I, then G is an antiderivative of F on the interval I, if and only if and only if, should I phrase this? G is of the form G of X equals capital F of X plus C for all X in I, where C is a constant. Okay. So basically, G is the original function. The derivative would be lowercase f. So if you took the derivative of G, notice how that C would disappear, right? So G is also called the general solution. So C can be anything, meaning there's an infinite number of solutions. Now, the operation of finding all solutions is called anti-differentiation. or which we'll end up calling it indefinite integral or integration. And is denoted as this here. So this little weird S thing is the integral symbol. And then you have to do integrate with respect to a specific variable. So dx, that will equal capital F of x plus c. So this is the general solution, G. So lowercase of x is called the integrand. Dx is the variable of differentiation. Capital F of x is the antiderivative of f of x and c is the constant of integration. Basically, the integration is like the inverse. I guess I'll make a note of that. Is the inverse of differentiation. They undo each other. So if you were to integrate something that had a derivative quote, dx, that would simply just be f of x plus c. Now, if you have the derivative of an integral with respect to that same variable, you would just end up with a function. So they would basically cancel themselves out, leaving with the original integrand here. Okay. Let's start let me write down the basic rules that you're going to need for this section here. So wait a second. You guys cool on this page? Yeah, let me write the integration rules then. Just let me know. This is what we're mainly going to need here. 1, the integral of 0 with respect to x would be some number, some constant. Because we know the derivative of a constant is 0, right? So the antiderivative or the integral of 0 should be some constant. That constant could be anything though. Integral of a constant k would be equal to k times x. Right? For example, if this was like a 4x, the derivative of 4x would be 4, right? The derivative of kx is some k. Does that make sense? Number 3. Integral of k times f of x dx. There you can actually pull the constant out and worry about it later and just integrate the integrand part. And then multiply it times your answer. Okay, sorry, got distracted. So number 4, if you have two functions that you're integrating together, you can separate them and integrate them separately. The next one is the most important one, and we're going to see quite a bit, is the power rule. So if you have x to some number, the antiderivative will be that number plus 1 over that number plus 1. So where n cannot be -1, k is some constant relevant to the real numbers. Integral of cosine.
Just curious, what does K stand for?
K is an element of the real numbers.
Okay.
Some number that's not 0. So for example, if you were to integrate 2, right, you would get 2x plus c. That's what number 2 is saying. Number 6. Antiderivative of cosine would be sine because the derivative of sine is cosine. Antiderivative of sine will be negative cosine because the derivative of negative cosine is sine. The antiderivative of secant squared x dx would be tangent because derivative of tangent is secant squared. Antiderivative of secant tangent would be secant. Antiderivative of cosecant squared x dx would be negative, oops, sorry. No, that's right, that's right. It would be negative cotan x plus c. 11. Antiderivative or integral of cosecant x cotangent x dx is equal to negative cosecant x plus c. Number 12. The integral of a number to the x dx is equal to 1 over ln of that number times that number to the x plus c. Look at this one. Sine, cosine, secant.
Is that 1 and a
ln a.
ln a? Okay.
Oh, yeah, that's right. 13 integral of e to the x dx will be itself plus some constant. And the final one, integral of 1 over x dx, or integral of x to the negative 1 dx, is ln x. Plus. These are pretty much all the basic rules that will be popping up throughout chapter 5. We'll give them all to you now. And I'll wait a bit. We'll start some examples. You guys go on this page?
Yes, sir.
All right. Let's start some examples. So the first few questions in your homework are going to be about solving, finding the solution to a differential equation. So, but I guess before we get there, let's do some really basic stuff. Find the antiderivative. Just get used to it. So part A, integrate 2x squared cubed. Right, rule 3 says we can completely pull out that 2 and ignore it. Right? Rule 5 says you apply the power rule for antiderivatives. So that would be 2. That 2 is just going to be there till the end. So you add 1 and you divide by that same number. But once you've integrated, you have to put the c. Otherwise, it's wrong. There'll be 2x to the 4th over 4, which reduces to x 4th over 2 plus c. Any questions on this property or the power rule. That makes sense.
I'm trying to follow. Give me 1 second.
Yeah, power rule says to undo the derivative, you take whatever number's there, you add 1, and you divide by that same number. Just like before, when we did the derivatives, we would subtract 1, right? And bring the number down in front. So now we're adding 1 and dividing instead.
So then for the last part where it says x over 2, is it 2 because, well, did you move the 2 down, or why is it 2 at the bottom?
Oh, they just reduced 2 or 4.
Oh, okay.
Do another one. X squared plus 3 dx. Integrate this guy. So the rule says that you can separate this into 2 different integrals. Right? We know the rule 4. Rule 4. And then apply the power rule to this guy. So that will be x 2 plus 1 over 2 plus 1. That's rule 5. Yes, it's not weird. Yeah, that's fine. And then this guy would be simply 3x. Of course, we got to add our c. This will be rule 2. Right, so the antiderivative of any number, k, will be k times x. Finally, the answer will be up over here. Now, x cubed over 3 plus 3x plus c. Do these steps make sense? What is the derivative of 3x?
It's just 3, right?
3, right? Which is what we started with. You see how it works, right?
Yes.
Derivative,
then-
derivative of this is going to be
It's gonna
3x
be
squared.
yeah. See, so derivative of this will be the original. The antiderivative gives me this guy. So it's one way to check your work. You can take the derivatives of your answer and see, is it the original? Yeah, good. And of course, the constant would be 0, so who cares? Now, in like real life problems, C would be determined by like an initial condition, like the position or temperature, or time, whatever problem we're solving, will then dictate what C looks like. But right now we're just doing general stuff. We're solving this guy, so we got some C. Any questions on A or B? Okay. All right, then, so let's get to the homework then. The homework is slightly different, but we need to make sure we're comfortable with these rules. So number one says find the general solution of the differential equation and check the results by differentiation. So basically, they're giving you a derivative. They want you to integrate both sides, which would mean you're solving for y, you're going backwards to the original. Once you get the original, you take the derivative just to see if it works. That's what they want you to do. So let me write this guy down here. Find general solution. That's number one. So what you have to do is integrate both sides.
Is that a 2/7?
Yes. So remember I said the derivatives and antiderivatives will cancel. So this will basically leave you with y, the original function. So y is equal to this antiderivative. So you start to see the usefulness, right? So if this was like velocity function, then I can integrate it and find the position. So if all that information that I have is acceleration or velocity, then I can go backwards, right? Which is pretty cool. So solving for y is a big deal because the solutions can be all kinds of real life problems. So knowing this will then be able to, predict things or tell you how fast it was going, where you're at, what was the temperature. Like if you have the change in temperature, but you want to know what was the temperature at a specific time, well, you solve for y. So it becomes all kinds of things. Basically, it just becomes very applicable. Anyway, so we have a rule that says we can just ignore that 3. Right? I think that was rule 3. Yeah. And then rule 5 says do the power rule. So that would be x to the 2/7 plus 1 over 2/7 plus 1. That makes sense. If you look at rule 5, right, you just add to whatever power is there, you add to 1. Although our power is now a fraction, so that kind of sucks. 2/7 plus 1 is going to be what? 9/7, right? Over 9/7, which is so that will become, flip the fraction over and multiply. That'll be 3 times 7/9 times x to the 9/7. So our final answer will be 7/3 x to the 9/7 plus c. Any question about those steps? Does it seem okay? It's not too bad, right? So the general solution, y is equal to 7/3 x to the 9/7 plus c. Your answer. You guys cool on example 2? All right, well, let's check the work, see if it's legit, right? You guys cool on this page?
Kind of.
Okay, okay, wait a bit.
So dx is just the constant, right?
Dx is basically telling me what variable the original function was
Oh, okay.
differentiated with respect to. I like to think of it as it's just reminding me of what a variable I'm integrating with respect to. Which I mean doesn't matter in this class, but in Cal 3 or whatever, I integrate this function with respect to different variables. Because usually that's like you're dealing in 3D, so you know how we've been doing area, right, with the integrals and stuff with the no, I guess we'll talk about that later. Check example 2. So we found y to be 7/3 x to the 9/7 plus c. Is that in fact the derivative? So let's find out, or the solution. Take a derivative with both sides with respect to x and find out if it's correct. So we're checking our work. So to the left-hand side, well, that's just going to be dy dx, right? Using our rules of implicit and all that stuff. Over here, you can do derivative of this guy, which will be it'll be 7/3. Bring down the 9/7, right? Subtract 1 9/7 minus 1. Derivative of a constant is 0. These 7s will cancel. So now I have dy over dx equal to 9/3 x to the 9/7 minus 1 is 2/7. And yeah, it looks like we're correct, right? That's what we started with. So you can always take a derivative to find out, is it true? Any questions on example 2? I'm not gonna keep checking them, I just wanted you to see how they turn out to be the same. How it goes, just undoes itself. Okay, so number 2 is the same type of deal. Number 3 and 4, they're testing you to see if you can rewrite these problems. So let's do 3, I guess. So 3. The integral of the 4th root of x dx. Okay, switch over. I'm not going to complete the table. I'm just going to show you how to do it. Okay, so remember how when we were doing derivatives, if we had a square root, we would rewrite the problem, right? You would change this into a fractional power. So same thing here. Changes into x to the 1/4. And then apply the power rule. So that will be x to the 1/4 plus 1 over 1/4 plus 1 plus c. There is my antiderivative or my integration. Add those fractions up and you should get x to the 5/4 over 5/4, which is going to be 4/5 x to the 5/4. There it is. Any questions on number 3? That make sense?
Yes, sir.
No, it doesn't.
Did someone say no, it doesn't?
It doesn't? Well, let me know if it does not make sense.
I thought I was hearing things.
I think that was, I walked away while I was talking, I'm sorry. But you see, all we're doing is applying the power rule, right? +1, +1. This symbol is telling you to integrate, which means add 1. So let me switch back. I'm gonna update my left. Okay. So here they want you to, it wants you to show them the steps. So first step, rewrite it. See how they want you to put a 1/4 power. Next step, add 1 to the power and divide by the result. So 1/4 plus 1 is 5/4. Divide by 5/4. And then when you divide by a fraction, that's the same as multiplying by the reciprocal. So that's how you got this. That's pretty much what we did. 4 is a little harder, but the same kind of thing. 5 is different. Let's see. 6 looks more annoying. Let me do 6 for you. So find the integral.
Oh, that worried me. And I was looking at number 5, and when you had the cursor over it, it looked like a really long answer. I was like, oh my God.
No, it's just the way they wrote it, right?
Yeah, they got.
It's not too bad. I think chapter 4 is maybe a little harder. Okay. So find the antiderivative of square root x plus 1 over 4 square root x. So remember how we said we can separate them. So let's use that rule to separate these two terms into two integrals. Then rewrite the first one as a 1/2 power. This guy pull out 1/4. We can go ahead and rewrite this, I guess. So that'll be 1 over x to the 1/2, right? So we move that to the top and we'll be ready to integrate. So that'll be integral of x to the -1/2 dx. So now we're all ready. We're started into the form that will let us use the power rule straight up. So remove the symbols once you start integrating. So 1/2 plus 1 over 1/2 plus 1 plus 1/4 x to the -1/2 plus 1 over -1/2 plus 1, right? That's the rule. 1/2 plus 1, that's going to be 3/2, right? Plus -1/2 plus 1 would be a +1/2. So +1/2 is down here. So now we deal with these fractions. We're dividing by fractions. So that's the same as multiplying by the reciprocal. Reciprocal. Two-thirds x 3/2. Multiply that out, that'll be 1/2 x. No. Yeah, that's right. Let's see. Okay. Any questions on the steps? You see how we applied? I mean, all the first half of it is just setting it up, right? Just doing some algebra to prepare. This from here to here is the actual integration. After that, we're doing more algebra. So this is the calculus step right here, you guys. Any questions on any of these steps?
No, sir.
Does it make sense? All right, so number 5 would be an easier one compared to what we just did. 7. That's whatever. Now let's do. Let's do 10, I guess. That's cool on that page.
Yes, sir.
Let's do a couple. 5. Problem. 9. Integrate, let's do this guy first. Theta squared plus secant squared theta, d theta. So don't let the variables change density. It's the same thing. Just pretend it's an x, right? So first thing we should do is separate them and integrate each part. Just remember that the trig functions have their own rules, right? You just have to either memorize them or have them on a note card or formula page. So, integrate this guy. Integrate this guy separately. So this treated like you would just a basic power rule. 2 plus 1 over 2 plus 1. This guy you need to remember from your formula or from derivatives. So going backwards, what's the derivative of tangent? Do you remember?
Is it sine over cosine? Or is it secant?
The derivative of tangent.
Oh, tangent.
Going back to chapter 3, what was the derivative of tangent?
It's just secant squared, right?
Yeah,
think-
secant squared, so I'm going backwards. The answer was tangent, right? Does that make sense? Because derivative of 10 secant squared, so antiderivative would be 10. So if you remember your derivatives, then you can always go backwards, or you can use that sheet I wrote down for you. Whatever you want. The answer will be this. Okay. Any questions on number 5? Integral of, this is number 10. Let me write that down. Integral of 3 sine x minus 7 ex dx. So separate them. And then pull out the numbers that are in your way. And then use your formulas. What is the antiderivative of sine?
Isn't it cosine?
I believe so. But is it positive or negative?
It's positive.
Because derivative of sine is cosine.
Oh, my bad. It's it's negative cosine.
Yeah, negative. Because derivative of negative cosine is positive sine. So you can always check yourself by remembering derivatives. Derivative of EX, or antiderivative, sorry. It's just itself, right? Just like the derivative. Just make sure you add your C whenever you're done. It will always be a C if it is indefinite. Okay, that's pretty much it for this section. Is that making sense? Seem doable?
Yes, sir.
It's more about practicing the steps and getting into the groove of it.
Yeah, pretty much. You just gotta keep those rules handy so you can look at them. You don't have to memorize them unless you want to. Won't stop you.
Yeah, can you open up the modules for 5.1?
Yeah. Thanks for reminding me here. 1 second. Yeah, it looks like. They are open, but let me see. The module, you're saying the module's not, right? We can't see it.
Yeah, the last one that was open was 5.6.
Oh, here it is. I went ahead and opened all the modules. Still need to adjust a few things, but you can see them now.
Thank you. Are we skipping 5.3?
Hold on. Pause this.